Okay, so in the last video we took a look at the cold front and the warm front, and what I wanted to do in this one was take a look at the occluded front and just a really brief overview of the stationary front. So we also have, in addition to the cold front and the warm front, what's called an occluded front. And with the occluded front, it's sort of a combination of the cold and warm fronts combined. So in an occluded front, we have our cold front. So we'll start out with that. And let's label the ground again. And again, this is a side view. And we've got, we'll start out with drawing something, well, essentially a cold front. So I'm going to draw my kind of bulldozer-shaped blob of air that would be pushing its way through the warmer air because it's more dense. But what's happening is that the cold front, in this case, has caught up to the warm front. The cold front's moving faster. The warm front isn't moving as fast. The cold front and the warm front catch up to each other, and they sort of combine together. And what you end up with is a situation where you have something that looks kind of like this. And now we've got our cooler air, or our cold air here. And now our warm air has nowhere to go but gets pushed upward. Okay, so we basically have a combination of a cold front and a warm front together. Now, you end up getting some precipitation around here, but it's a mixed precipitation. And when I say mixed, I don't mean like wintry mix. I just mean like you could get some thunder and lightning. You might get the slow, steady rain. It's moderate precipitation. And not easy to predict and not easy to forecast. But what's also interesting about this is that now we have some warm air above the ground. And if you remember, I think I've mentioned this a couple times, usually when you go higher up in altitude, the air gets colder the higher you go, as long as you're in the troposphere. In this case, though, the air would be getting colder as we went up. But then we now hit this pocket of warm air, and we would call this a temperature inversion, just meaning it's flipped around compared to the way that it normally is. So normally it would get colder the higher up we go. In this case, we go higher up, and it gets warmer. We hit this warm layer of air. And I'm saying moderate precipitation here. It's kind of unpredictable. You have the effects of a cold front and a warm front kind of combined. It's not as predictable as the weather that we could associate with a cold front and a warm front. On a weather map, this is going to be a purple colored front. Okay, so it's going to be purple on the map. And what you'll often see is something that looks like this, where you're going to have maybe a cold front, and then you would have something like this, and this would be labeled warm front. And here, where it would be shaded in the purple, is the occluded front. The cold front has caught up with the warm front, and it's starting here, but the cold is going to catch up to the warm, and it's basically the whole thing is going to close sort of like a zipper on a jacket, and the whole thing gets closed up. And I like to kind of think of the occluded front as sort of the beginning of the end. When you see the occluded front appear on a storm system like this, it means that the storm is starting to lose energy and it's fading out. When the whole thing becomes an occluded front, it's not going to last much longer, and it's essentially reached the end of its life cycle. And now let me pause the video for 1 second. I want to show you something now that I think of it. Okay, we're back. What I wanted to show you was what's called cyclogenesis, which essentially is how a front or how a low pressure system develops, moves across the United States. So we often start out with a stationary front, and we'll talk about stationary fronts next. But the point is that we end up with a low pressure system. We've got a cold front and a warm front attached to that low pressure. This is the textbook situation. It's not always what you really find in real life. Now, the cold front, since it's moving faster than the warm front, is going to start closing the gap between them in what's called on excuse me, on this diagram, the warm sector. So this starts closing up, and the cold front starts catching up to the warm front. And when it actually meets, when the cold and the warm air meet, the warm air gets forced upward, and now we have the occluded front, which you can see here, shaded in purple. And then eventually it's going to, the whole thing's going to become occluded, and then it breaks down usually over the ocean. So that's the typical life cycle of what we would call a mid-latitude cyclone, just a low-pressure system in North America. Now, that brings us to the stationary front, and actually before I pull up the camera again, we can kind of see it here. Alternating circles and blue triangles. But what's happening with the stationary front, and it's kind of hard to draw, but we'll sort of give it a shot. Over here, we'll label this, this is our last front, the stationary. And the stationary really lives up to its name. It doesn't really move much. And if we look at this in a different perspective than the other fronts, if we look at this from a top view or a map view, if we have our front here, there's very little mixing of air. We have one air mass on one side, and we have the, maybe I'll label it air mass 1, and over here I'll label this air mass 2. And there's only just a little bit of mixing right along the border, so we do get some precipitation at the front, but with little movement. I've been told that it's sort of like the air moves like laterally or sideways, but not like across the boundary. I'm not certain exactly how true or how accurate that is, but it's more like the air is moving along the boundary instead of across it, which means with the stationary front, you'll have a slow, steady rain. But because the stationary front doesn't move much, if you're under the stationary front, there's a little person there, you're going to see a long duration rain. It might last days, maybe several days, maybe even in the neighborhood of a week. Yeah, so not really like severe weather. You're probably not going to get thunder and lightning. Just slow, steady rain that lasts a really long time. Eventually it'll clear out or break down, but you have very little mixing of the air, so you have precipitation along the front, long duration rain that's going to last several days, maybe up to a week. Okay, so those are the basic fronts that you need to know, particularly the cold front, warm front, and you should be at least familiar with the occluded and the stationary fronts. Okay, so we're through the heavy stuff now. There's some details and some smaller things that we need to take care of, but that's some of the bigger concepts in this unit. So anyway, that's it for now, and hope things are going well. And again, always feel free to email me with specific questions or problems. Okay, good luck.